All right, so now that we know a little bit about electrons acting like waves, in essence, we know a little bit more about waves. Let's take a look at the fact that since they act like electromagnetic waves, let's look at the electromagnetic spectrum. Electromagnetic spectrum is dealing with the electromagnetic waves and the whole range of them. I'm not going to give you them all, but we're going to talk about the fact that we have different waves that have different wavelengths, therefore they behave differently. Okay, so that's kind of the electromagnetic spectrum. Now, you all know the colors of the rainbow, right? The colors of the rainbow, Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. All right, Roy G. Biv. And we've learned those before, and we've thought about them as rainbow, but or the colors of the rainbow. But we haven't really thought about them as electromagnetic waves, and therefore part of the electromagnetic spectrum, I bet. And so when you think about the electromagnetic waves, and I'm going to actually change this a little bit, okay? There we go. All right, so notice my drawing here, and I wish I had flipped it around, because of course I've got the red over here and I've got the red over on this picture, but it was the best one I could find on the internet. But basically, notice we've got this spectrum where red is over here, violet is over here. The separation. The reason that we have separation is because they have different wavelengths. And you can see real quick over here that red has a longer wavelength, 700 plus nanometers, to violet, which is in that 400-ish or so nanometers, okay? So there's your colors of the rainbow and the way that we kind of can separate them. Now, I'm going to show you what that does for you in just a second. But let's go ahead and look a little bit more at the electromagnetic spectrum. Okay? So, red, longer wavelengths than violet. Let's just understand that. And again, it's kind of in this 700, 750 nanometer to like 400 nanometer range. Okay? Now, we do have some waves, I guess I'll go smaller here, we do have some waves that are lower in terms of length of the wave, the lower wavelength waves. Right near violet here, if we've got violet right here, that's the violet one, notice that we have ultraviolet waves, or in other words, UV. So UV waves are shorter than the colors. This, of course, is visible light. When I'm talking about the visible light, all the colors of the rainbow, that's visible light. But ultraviolet rays are shorter than the color spectrum. So since they're shorter, they have a lower wavelength, which means higher frequency, which means higher energy. So these waves here, ultraviolet, and as you can see moving away here, are more dangerous for you because they are waves that have higher energy, which makes sense here. We get our UV, and right near that is X-rays. X-rays have a wavelength of somewhere around, something times 10 to the negative 10 meters. This is the wavelength in meters, as you can see. Okay? So right near violet is ultraviolet, right near that is X-rays, and then we have our gamma rays or gamma waves. And I had mentioned that gamma waves are extremely dangerous. They're only stopped by lead. That's the type of radiation that comes out, nuclear decay. So pretty dangerous waves. If you go in the other direction, right near red, and again, here's my red part of my electromagnetic spectrum. Right near red, I have infrared, or IR you could call it, infrared waves. Infrared is right near red, makes sense. Next to that, and that's why I kind of cross these out, are microwaves. Microwaves are right near infrared. They're longer, okay? Next, TV waves. TV waves. And lastly, radio waves. And radio waves have very long wavelengths. Long wavelengths, short or low frequency, low energy. That's why radio waves are all around us. Obviously, if I turned on a little transistor radio right now, I could hear it because there's radio waves in the air. If there were gamma waves in the air, not so good for me. So again, the difference there being the wavelength. Okay?